All right, y'all. Really exciting stuff for you today. Remember how I told you limits aren't the only way to take derivatives, and I was going to teach you some fast, fun tricks to take derivatives. I hope you remember that. Well, today is the day you get to learn those fast new tricks. So make sure that you're getting notes down. Today's notes, 2.4 notes, the power rule key. This is going to make taking derivatives 1 million times easier, and I'm really excited for you to learn it. Okay, so first, we're gonna have like multiple rules that you write down. This is the first rule, derivative of a constant function. And here is the rule, the derivative of a constant function is 0. For any real number c, so this is a constant, here's the rule like written out mathematically. For any real number c, this little thing means the derivative with respect to x of c equals 0. Okay, so the derivative of a constant is 0. Really quick, I'm going to draw a graph of a constant. Let's say f of x equals 3. This is a constant, right? That's c, the constant. Let me graph that. If f of x equals 3, that means that y equals 3, like all the time, right? That's what that's saying. So a graph of this would look like that, right? Okay, this is f of x equals 3. Why is the derivative 0? Well, remember, the derivative is a slope of the tangent line. So if I were to draw a tangent line on this graph, no matter where I drew it, the tangent would be right on top of this linear function. And what is the slope of that tangent line? The slope equals 0. Slope of the tangent line is 0. That's why the derivative of a constant is 0. Okay, so let's get some examples down. This will be very quick. So derivative of a constant, if, these are your examples, get them down, if y equals -4, and we're going to write the derivative over here on the right-hand side, y prime, that's the derivative, equals 0, because the derivative of a constant is 0. Okay? If f of x equals 3 pi, we're going to write f prime of x, that's the derivative of x, equals. All right, students often get tricked by this one. Y'all, is pi a variable or is pi a number? Pi is a number. It's just a number. It's like 3.14. It goes on forever, right? So 3 times pi, well, that's 3 times a number, which is just a number, which is a constant. So this whole thing is a constant. So what is the derivative of a constant? F prime equals 0. Sweet. This one also tricks students a lot of the time. G of x equals e. What is e? 2.71 it also goes on forever, just like pi. Okay, so what is the derivative? G prime of e? Well, since e is a constant, it's just a number. The derivative equals 0. Yay. Okay, you could use the limit definition of the derivative to find all of these derivatives, but this is way faster, right? All right, let's learn another rule that's going to save our lives. Here we go. The single variable rule. The derivative of x is 1. Okay, and then again, the way that we read this, the derivative with respect to x, that's the denominator part, of x, the derivative with respect to x of x equals 1. That is the mathematical notation. And then think graphically about the line y equals x. So let me draw that for us really quick. This is the line y equals x. So let's say f of x equals x, which means y equals x, because f of x is the same as y. All right, well, remember, derivative is slope of the tangent line. For a straight line, for a linear function, the tangent sits right on top of that function. And what is the slope? M equals 1. Because the line is a straight line with a slope of 1. The y equals x line. So let's do some derivatives really quickly. F of x equals x. What is f prime of x? F prime of x equals, well, according to this rule, the derivative of x is 1. Cool. What about if we have a function that is has a variable of t in it? Well, no big deal. A prime, the derivative of a with respect to t equals, this is still my input variable, so it's going to be 1. A prime of t equals 1. All right, new rule. they're going to get more and more helpful as we go. Here's another rule. The power rule. Write it down. Huge, very important rule in calculus. Super cool how fast it is to take these derivatives. Way faster than taking them using the limit definition of the derivative. Okay, if n is a rational number, that could just mean like a number or a fraction. It's just a number. Okay, if n is a rational number, then the function x to the n, so our function f of x is going to look like x to the n. It's some x value raised to the nth power, to the number power. X to the n is differentiable. That means you can take the derivative. If you don't know that yet, write it down. You can take derivative. That's all differentiable means. Okay, so x to the n is differentiable, and the derivative with respect to x of x to the n equals, all right, here is the rule. So please write down, we're going to write down all of this. The derivative with respect to x of x to the n equals n times x to the n minus 1. So what did they do there? They took this number, they took the number n, and they put it out in front, and then they changed the exponent, subtracted 1 from that number n. Cool? Let's do some practice. Okay, so we're going to start with this problem. F of x equals x cubed. F prime of x. Well, first of all, n equals 3 here, right? That's the exponent that our x is being raised to. Okay, so the derivative of f will be, take that 3, put it out in front, 3, and then n to the 3 minus 1, which equals 3n squared. All right, really quick over here, I'm going to show you kind of how I visualize this. I imagine taking the exponent, dropping it in front, and then just subtract 1, minus 1, up there on the 3. And that's how you get your derivative. All right, so let's go ahead and do that with this second example. F of x equals 20, or x to the 20th. Take that 20, drop it out in front. So f prime equals 20x, and then subtract 1 from the 20. 20x to the 19th is your derivative. Cool, I want you to try this. Oh wait, just kidding. Let's rewrite this one first. So, okay, sometimes you will need to rewrite. Sometimes you will need to rewrite this to get it with an exponent. We need an exponent. Like, this rule requires that you have an exponent, right? So we need to turn this square root into an exponent, and hopefully we remember what the square root of x is the same as. So before I even take a derivative, I'm just going to rewrite this with the square root as an exponent. So square root of x equals x to the 1/2. All right, cool. Now that we have an exponent that's n, right, we can use the trick. So go ahead and do that one on your own, please. Put your answer in a puzzle. Okay, so we should have gotten 1/2 comes out in front. Then we have x to the, now we might need a refresher on subtracting fractions. So I'm going to do this. I'm going to do 1/2 minus 1. And then I'm going to come over here and remind us how to do that. 1/2 minus 1 equals. All right, y'all, really quick, when you're subtracting fractions, the fastest way to do it and the easiest way to think of it is to just put the 1. The 1 is going to be the denominator over the denominator. So same denominator. It'll be 1/2 minus 2 over 2 because our denominator is 2 here. So you'll just put like same over same, 2 over 2, that equals 1. This thing, 2 over 2, equals 1. So we're just writing a common denominator. Okay, so 1/2 minus 2 over 2, well, that equals negative 1/2. So we simplify this and we get 1/2 x to the negative 1/2. All right, here's the thing, y'all. For multiple choice, we're going to have to know how to convert this answer that we have. We need to convert this thing back to like a root form. square root form. So let's go through a reminder of how to do that. First of all, negative exponents make the term forced into the denominator. It flips like the position of the term. So we're going to say equals 1/2, and the x to the negative 1/2 is going to get forced into the denominator, and the 1/2 turns positive now. So once you force it into the denominator, the exponent turns positive, and then x to the 1/2, this thing, x to the 1/2 is the same as square root of x, right? So we get equals 1/2 square root of x. Whew. Okay, that was a little bit of algebra. We are going to get better at that as time goes on, but we do need to be very fast at converting things from roots to exponents, from negative exponents down to the denominator, all that jazz. Okay, so let's go ahead and do a few more kind of difficult ones. We are here at f of x equals 1/x. We need an exponent, just like up here. We need an exponent. I don't see an exponent. Well, let's rewrite this thing, this 1/x, as x to some exponent. So equals x to the, and what is an exponent right now on x? It's 1, right? But the x is in the denominator. That's a problem. We need it to be in the numerator to use this rule. We need it to just be like x by itself. So remember, if something is in the denominator, it can have a negative exponent if you want to put it into the numerator. So when you move something with a positive exponent in the denominator, you want to get it out of the denominator, you just flip the sign on the exponent. That puts it in the numerator. Okay, so now let's do the derivative. F prime of x. We're going to take the -1 out in front, -1x, and be careful. Then we're going to do -1 minus 1, which equals -2. So we have negative x. I don't need this -1, right? Negative x to the -2. And again, we need to represent our answer in a form that the multiple choice will take. So something like this. So we can't have a negative exponent, equals negative. When we are flipping this, we have 1/x to the +2. The exponent turns positive when we flip it. That is our derivative of 1/x. Okay, let's do this x to the 0.4. The derivative would be take the 0.4, put it out in front, 0.4. X to the 0.4 minus 1. And really quick, y'all, I just want to talk about short answers. So we've been talking about multiple choice and how they will represent your answers in multiple choice. Let me make a note that is what's happening here in these green. Multiple choice. But for short answer, you are allowed to leave your answer like this. So I want you to be aware of that. You are allowed to be lazy sometimes in calculus. And I would encourage you to be lazy on short answer if you're allowed to be, because then we won't make any simple mistakes. For short answer, you're allowed to leave your answer like this. You do not have to simplify the exponent. You don't have to do that subtraction. Okay, now that we know the difference between those, let's go ahead and move on to our fourth rule. The general power rule. Okay, so write this down. We have the general power rule, the derivative of the term ax to the n, where a and n are numbers, real numbers, is a times n x to the n minus 1. Okay, and then all this is saying, y'all, I want you to write this version down. If a constant or a number is in front of x, just leave it. Just leave it and multiply. Okay, and I will show you examples. So let's get these examples down. We have our first example, y equals 3x squared. All right, our constant is the 3. Our constant out in front, that's like the a here. it's just going to chill there. It's going to stay out in front. And we're going to take the derivative just like we did last time, using that like x to the n minus 1, bring the n out in front thing. But we're going to multiply it on the constant. The constant's just going to stay there. So y prime equals, bring the 2 out in front, but multiply it by the 3. So I'm going to write this one all the way out so that y'all can see what I'm doing. It's going to be 2 times 3. And then we need our x to the n minus 1, 2 minus 1, equals 6x to the 1, which just equals 6x, right? That's our derivative of 3x squared. All right, cool. For v of t equals negative 5t cubed, we are going to take that, multiply it out in front. We get v prime of t equals negative 5 times 3 is negative 15. T, 3 minus 1 is 2, so negative 15t squared. Sweet. And again, sometimes we will have to rewrite these to look nice and pretty for us before we take a derivative. So let's rewrite the equivalent. This is the same as 6x to the 1/2, which the derivative of that, g prime of x, would equal, multiply the 1/2 out in front, 1/2 times 6 is 3. And then we have x to the 1/2 minus 1. 1/2 minus 1 is negative 1/2. If we were going to have a multiple choice problem that looked like this, we would have to know that this negative 1/2 pushes down into the denominator. So we get 3 over x to the positive 1/2. And then we would have to know that the exponent 1/2 is the same as square root, so equals 3 over square root of x. That would be for multiple choice. So again, this is for short answer. You're allowed to use it, leave it like this for short answer. And then for multiple choice, you'd have to get all the way to here. I'm going to write a note of that. Short answer, multiple choice. Sweet. Let's move on. Make sure you rewrite them when they're not set up in like a exponent form. So we have, or like when they're not set up with your exponent being in the numerator. So we have x squared in the denominator. We need to say what this is equivalent to. That would be the same as 3x to the negative 2. Cool. So then y prime equals, bring the negative 2 out, multiply it. We get negative 6 x to the, okay, students always get this one wrong, so I'm going to write it out. Negative 2 minus 1, that's negative 3. So negative 6 x to the negative 3, and then if I was doing multiple choice, this would be negative 6 over x cubed. Cool. Students often forget how to rewrite this thing, this next one. They often forget how to rewrite this root. So let's make sure we know how to do that. This is the same as, f of x is the same as negative 2 times, actually, let me just start by like rewriting the root. So this is the same as negative 2 over, and then this is x to the 4 thirds. That's how that root is rewritten. Then we need that exponent in the numerator instead of the denominator. So let's move it and flip the sign. So we get negative 2 x to the negative 4 thirds. All right, and now let's make sure you know how to do this, this math. So we get f prime of x equals, multiply negative 2 times negative 4 thirds. I have had students struggle with this, so I'm going to like actually show you what to do here. Then we're going to do times x to the negative 4 thirds minus 1. Okay, we need to go through this whole thing because I know that y'all sometimes struggle with this. First things first, this multiplication. A whole number, the negative 2, when it's multiplying, when a whole number is multiplying on a fraction, it only multiplies to the top. So you can just think of like multiplying this negative 2 times negative 4 and then simplifying or like leaving the 3 in the denominator. So what is negative 2 times negative 4? That is positive 8 over 3. Okay, that's how that number simplifies. And then we need to write x, and then we need to remind ourselves how to do this subtraction. So I'm going to break off a little bit. Negative 4 over 3 minus 1. Remember, I said you should try doing negative 4 over 3. If you're doing minus 1, just put the denominator over the denominator when you're subtracting 1. So minus 3 over 3. That's the same thing as 1, right? 3 over 3 is equal to 1. Okay. So now we're going to do negative 4 minus 3. That's negative 7 over 3. They have a common denominator, so now you can just leave the denominator. Sweet. And now that's our new exponent. So this is our new exponent. Let's put it on x, negative 7 over 3. This is a short answer acceptable solution to the derivative, but if we were going to write it in multiple choice form, we would need to push the x down into the denominator. So we have 8 over 3x to the positive 7 thirds, and then we would need to convert it to a root. So equals 8 over 3, and then you have cube root of x to the 7th. All right. And then that would be our final multiple choice answer. Cool. Last one, y'all. 77x. All right, what's the exponent on x here? Question, what's the exponent on x here? 1. So we're going to multiply the 1 to the 77. So we get g prime of x equals 77 times 1 is 77. And then we get x to the 1 minus 1. Well, what is 1 minus 1? 0. So that equals 77 x to the 0. What is x? What is anything to the 0? Anything to the 0, anything to the power of 0 equals 1. So this is the same as 77 times 1, which just equals 77. Cool. So y'all, when we have a constant and your exponent on x is just 1, you will just get that constant, g prime of x equals 77. That's your derivative. The constant is your derivative. Cool. Let's move to our very last rule, sum and difference rules. So the derivative of sum and difference rules, make sure you write it down. The derivative of a sum or a difference is the sum or the difference of the derivatives. So all this is saying, y'all, is that if you're taking the derivative of f plus g, you'll just take the derivative separately and then add them. You'll just like take each derivative one at a time. And then same with subtraction. If you're taking the derivative of f minus g, you'll take the derivatives of f and then subtract the derivative of g. All right, so I'm going to do 2 examples for this and then we're done with notes. The first one, f of x equals negative x cubed plus 5x squared plus 2x minus 8. We're going to use our rules that we just learned. So f prime of x equals, bring out the exponent, bring it out in front. So negative 1 times 3, that would be negative 3 x to the 2 because 3 minus 1 is 2. And now this is the sum rule. We just say plus and then do the next derivative. So bring out the 2, that's 10 x to the 1 because 2 minus 1. Remember that exponent is 1. And anytime the exponent is 1, you just get the constant, the coefficient that's multiplying. So plus 2. And then remember that the derivative of a constant is 0. So we could say minus 0. But we don't need the minus 0 probably on the end, right? Okay, so that is your first derivative. And now let's do this trickier one. And let's see, for this trickier one, actually, yeah, I'll just do it right here. Okay, g prime of x equals, let's multiply this fraction times 5. Remember, when you're multiplying a whole number times a fraction, you multiply the whole number to the numerator of the fraction. So 5 times 3 is 15. So in front, we get 15 over 2. Leave the denominator. And then we have x to the 3 halves minus 1. So 3 halves minus 2 halves. I'm just going to leave it like this for now, and then we'll simplify. Minus, let's multiply the 6 and the 5. So we have 30 over 3. We'll simplify in a second. X to the 5/3 minus 1, which is 3/3, plus, we need to rewrite this 4 over x. So I'm going to do that really quick. Let's go ahead and rewrite that. That's the same as 4 plus 4 times x to the negative 1, right? That's before we take a derivative. We haven't taken the derivative yet. Now we're going to take the derivative, so we're going to take that negative 1, multiply it out in front. So plus negative 4 x to the negative 1 minus 1. Let's now simplify. Leave fractions as fractions. 15 over 2 cannot be simplified anymore. Let it be. Leave it. Okay, x to the 3/2 minus 2/2. That's x to the 1/2. Minus 30 divided by 3 is 10. X to the 5 minus 3, that's 2/3. Subtracting the numerators. And then we have minus 4, because plus minus 4x to the negative 2. And this would be acceptable for short answer. So g prime of x equals, if you were doing a FRQ, a short answer question, you could leave it like that. But let's make sure we know how to simplify for multiple choice. Equals 15 over 2. You cannot have numbers in your, or fractions in your exponent. You have to remember, oh, that's the same as square root of x. Minus 10, we cannot have fractions in our exponent. X to the 2/3 is the same as cube root of x squared. And then minus 4 over, we can't have negatives in our exponent, 4 over x squared. All right, so again, we have a short answer version and a multiple choice version. And that is everything for today. This is multiple choice, and this one was short answer. Cool. Nice work, y'all. We are going to practice this a ton in class.